However, before we get started, I'd like to tell you a little tale. Way back in the mists of time, there were two programmers, a junior programmer and a sophomore programmer. They were hired for summer internships in a particular company. They both started on the same day. They got their specifications. They found out what the code they were going to be working on did. They split up duties and scopes and all the rest of this stuff. And then they were sent off to their cubicles. Well, the sophomore programmer, rather than writing any code, sat down and said, let me think about this for a bit and figure out how I want to lay this out and how I want to make all this work. And then proceeded to start writing notes on sheets of paper. The junior developer, however, started writing code. Now, there's a matrix manager in this thing. We know, although that can't be good news, and sure enough, it wasn't. The matrix manager, however, came in and saw the junior developer writing code and said, "It is good." The matrix manager went to the sophomore programmer and said, "What, no code? You need code." The sophomore programmer said, "I have ideas." The matrix manager said, "We don't need ideas, we need code." The sophomore programmer ignored the matrix manager. So a couple of days went by, and the junior programmer was writing more code. And it was declared good by the matrix manager. And the matrix manager was popping in 3 or 4 times a day on the sophomore programmer going, "Got code? Got code?" After about 4 or 5 days of having the matrix manager pop in 3 or 4 times a day, disrupting his thought processes, the sophomore programmer got annoyed and basically said, "Look, you thought I could do this job. If you think that has changed, then I will gather my stuff and leave right now. Otherwise, you need to leave me alone. I'm working with the technical manager. This is what I'm doing. I am not writing code." After about a week to a week and a half, and amazingly enough, the matrix manager actually went away. After about a week to a week and a half, the sophomore programmer went to the technical manager, sat down, presented his ideas appropriately typed up on green bar sheets of paper. I did say this was in the midst of time, and got her feedback, and got some good ideas from her about how to do this, and went off and spent a couple more days integrating the changes, made sure that he had everything right, and went back to the technical manager, and he said, "Yeah, this looks good." Then the sophomore programmer went off and started writing code. He not only wrote code, he wrote tests. And he also checked everything into RCS, so as he made incremental changes, like I said, this is the time, RCS. As he made changes, he could back things out and figure out what broke and all this sort of stuff, and every night his tests will automatically run out of cron. And the first thing he did in the morning was he checked his tests to make sure he hadn't broken something the night before, or the day before. Now, let's fast forward until about 3 weeks to a month before the end of the summer when their contracts end. At this point, the software programmer is actually done for about a week and a half. It's kind of in milk. So he takes his documentation, he takes his code, he goes to the technical manager and says, "Here is what I have wrought." The technical manager looks at it and says, "This looks pretty good. All your tests pass. Yeah, this looks fine. Give it to the full-time programmer." So the sophomore programmer goes and gives it to the full-time developer. And then the technical manager hits him up and says, "Since you've got so much time at the end of your contract, we'd like you to take a look at the junior programmer's code. Because he could use some help on it." Well, the sophomore programmer, who was rather naive, said, "Oh, sure. Could you give me the documentation about how it's laid out so I can have an idea about how this is put together when I go and look at the code?" The technical manager went, "We don't really have any of that." "Oh." So the sophomore programmer said, "Do you have anything other than code? Technical manager goes, "Well, no, not really." So the sophomore programmer goes over and starts looking at the junior programmer's code and realizes there's no source code control, so he's got no history as to how things arrived in this state. This state being, after 3 days of studying the code, he goes back to the technical manager and says, "You know what? I could spend the rest of my time here trying to understand this code and still not be able to make changes to improve it without worrying that I'd break something else? And the technical manager goes, yeah, it's kind of spaghetti code. It doesn't really work at all. Okay, let's do this. Let's try to remove some scope from his work and put it into your code. Here's what we want to do. Go figure out how to do it. So the sophomore programmer goes off and learns about things like indirect function calls in C and pointers to functions. And figures out how to actually do this stuff in one simple case. So he goes back to the technical manager and says, I think I figured out how to do it. I think this is how we do it. And the technical manager goes, well, that's good. Hey, why don't you go talk to the full-time developer? So the sophomore programmer goes and says, hey, full-time developer, guess what? Here's how I was told how to do this, and here's how we do it, and isn't this kind of cool and everything? And the full-time developer goes, yeah, that's of course how you do it, given how you structure the thing. I read your documentation. I did all of that stuff 3 days ago. So what we have here is a successful project where the person who's taking over from it can actually enhance it without actually having to spend months spelunking the code. And we have spaghetti code that all the marinara sauce in the world won't make palatable. What is this a story of? Is this a story of bad developer, no cookie? Or is this a story of bad company, no process? All in favor of bad developer, no cookie? One hand sort of half going up. All in favor of bad company, no process? Yeah, the company later went out of business. They weren't the Fortune 500, but they were pretty big in the area. My claim is that good process stops you from getting so far down the rabbit hole before you realize you're in trouble that you can actually correct it. If your process doesn't actually let you detect problems and correct the problems before they become critical, you've got a problem with process. So my vote is very much bad company, no process. And the question is, why should you listen to me? Well, my formal quality improvement training is actually from the field of emergency medicine. However, I was doing statistical process control in high school. I actually worked for a 1-hour photo lab and was responsible for running the Y55 forms to do the statistical process control on their film development lines. And basically, we're doing a lot of stuff wrong in IT. We seem to keep on having exactly the same problems again and again impeding process. We develop new tools without figuring out how people are actually going to work with them and how it's actually going to improve our efficiencies. And a lot of process steps change that just don't make any sense. And I'm not sure where the fault lies. I think it lies in us, but I think part of the problem is basically not looking at the process itself. Now, how many people here think process is a 4-letter word? I'm surprised. 7-letter word, yeah.
So does it have a triple word to it? I don't think stack rank.
Okay, I'll give you stack rank is a 4-letter word. Process is not a 4-letter word, but a lot of people go, process? We don't need no stinking process. Well, here's the joke. Everything has a process. The question is, can you identify the good elements of the process and repeat those while getting rid of the bad elements? The big reason a lot of process has bad, or a reason a lot of people have a bad perception of process is a lot of process gets baggage. Something went wrong with the process, so rather than actually investigating what went wrong, finding the real root cause of it, and solving the root cause, people throw Band-Aids on top of it, creating a lot of waste and a lot of wasted effort. So you end up getting this baggagey process that no one likes. Process itself is not a 4-letter word. What we do to the poor process, however, has many 4-letter and 7-letter words that can be used to describe it. Now what we're going to discuss specifically are 2 methodologies, Lean and Six Sigma. Now they both share a common base in manufacturing. Lean was really started by Toyota. Back many, many years ago. It sort of started as the Toyota production system. It was termed lean in the 1990s. Two of the big people behind it were the Toyotas, not Toyotas, Saiichi and Kichiro. Now, you may not know this, but the Toyota Corporation actually started as loom manufacturers, i.e. people who weave cloth, or actually create the machines that weave cloth. And one of the things that Saiichi Toyota noticed was you basically got a loom, right? You got thousands of threads spread out, all being fed at a very high rate of speed and moving up and down as shuttles go back and forth to weave this cloth. If the thread breaks, you're basically producing hundreds and hundreds and hundreds of yards of faulty cloth before it reaches an inspection point. Not only that, you've got this thread that broke, now still being fed furiously and gathering underneath the loom, where somebody's got to go in, detangle it from all the mechanics of the loom, and try to deal with this mess. His thought was, well, if the thread breaks, why don't we just stop the loom? Kind of seems obvious, right? And thus was born Jidoka. By the way, does anybody here actually speak Japanese?
Of course not, Jack.
There's Jidoka? Okay, cool. And if you see me mispronouncing Japanese words, please feel free to correct me.
Only if you're mispronouncing more than my faculty does.
Okay. Fair enough. Fair enough. Now, how many people here remember impact printers? Okay. For those of you that don't know, how many people here remember old-fashioned typewriters? Okay, better. An impact printer is basically a typewriter, but rather than typing one individual character at a time, you tap the entire line at once. So basically it goes ka-chunk, 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 ka-chunk as it types out each line. Just like your old-style typewriters, it uses a ribbon. Many years ago, a friend of mine set up to print off a whole bunch of source code that he needed for a class. It would take about a quarter or half a box of paper, 132 lines, white and green bar. So we set it up printing. We made sure it printed through the first couple of pages, and then we went off to dinner. We come back about half an hour, 40 minutes later to find about half a carton of paper nicely stacked in the back of the printer. It's all blank. Well, it wasn't quite blank. What had happened was the ribbon had broke. The machine didn't know that the ribbon had broke and proceeded to impress exactly every single line on the paper, but with no ink. So if you actually held the paper at an angle, you could actually see the text that was supposed to be there, but it wasn't particularly useful. Jidoka would have stopped this. He would have said, hey, ribbon broke, we're done, raise the error flag. This is termed autonomation. Automation that knows. A-U-T-O-N-O-M-A-T-I-O-N, for those of you that are Googling it. Now, that was Saiichi Toyota's benefit. Another thing he brought up was the 5 whys, which we'll discuss later. His son, who actually founded Toyota Motor Company, came up with the concept of just-in-time. That is, a flow to your work where stuff arrives just as you need it to reduce inventory, reduce waiting, and reduce waste. And then on top of that, there's another person called Taiichi Ono. I love Ono, because Ono came up with the 7 basic wastes. Ono waste. Wonderful. We'll discuss those as well in a little bit more detail later. Now, Six Sigma actually goes back to the late 1800s. At that point, there was a huge scientific revolution going on. And somebody thought, gee, wouldn't it be a great idea if we actually applied science to management? And thus scientific management was born. Some of you that are students of there may remember there were all sorts of motion studies and things of employees carrying heavy weights, the best way for them to pick it up, move it, most efficient, all the rest of this stuff. All of that stuff was sort of behind Six Sigma. Motorola was basically getting its head handed to it by competition in the 80s, 70s. And one of the people there said, look, we need to reduce our defects. This is ridiculous. We're doing so much rework. We've got so many problems compared to other people. Let's solve this. Thus was born Six Sigma. The concept behind Six Sigma, and which we'll discuss a little bit later, is basically removal of waste, removal of defects. One of the big people there was Bill Smith at Motorola. A couple of other more names that he built sort of his information on were Shewhart and Deming, who we'll also see discussed later on. The Shewhart basically came up with control charts. Deming came up with improvement cycles and other statistical things that built on Shewart's work. Now note, both of these come out of manufacturing. IT and service is not exactly like manufacturing. The tools and techniques are different, but the concepts are the same. And our trick is to apply the concepts within the IT framework. And we'll discuss some ways of doing that and some ways of thinking about it that have it make sense. Yes?
What are the origins of the actual terms theme, which is written, said that we're an acronym?
Six Sigma. Sigma is actually standard deviation. The concept of Six Sigma is that you want to have your process in such good control that by the time you get Six Sigma out is where all your errors are. That's all your unacceptable work. And we'll discuss that a little more. Like another slide coming up on that.
But Six Sigma itself is like 1 in a billion. Right? So it's
we'll discuss that when we get to the Six Sigma slide. There's some subtlety involved there that, for our purposes, doesn't really matter. But since you asked the question, I'll touch on it. Lean came from the people that were looking at the Toyota production system. They were basically saying, hey, they get more work done with less effort and all the rest of the stuff. Gee, this is kind of lean. And I guess that's where the term lean came from. It's not actually an acronym. There's a Wikipedia article, I think, on it that I got that story from. Whether it's apocryphal or not, I'm not sure. I didn't spend a whole lot of time researching the origin of the term lean. But that's where it came from. Now, what are our goals here? By the way, Lean Six Sigma is also known as LSS. So you know it's do more in less time, do more with less effort. Come on, it's a joke, folks. Less stress to do your job? Yeah, okay. Tough audience. Okay, I can tell this.
It's an engineer joke.
It's an engineer joke, exactly. But these are our goals. This is what we're aiming for. Okay? Especially in particular, the less stress. Don't be this poor guy. I truly feel sorry for him. Obviously, he just finished running a maze to get to the cheese at the end and figured out, hey, he has no cheese.
Who moved his cheese?
Somebody moved. Exactly. He has no cheese. Somebody moved his cheese, and it's just not pretty. All right. So here's a question: what is lean? And please notice, lean is actually leaning. Lean. I told you things wouldn't get better.
Here's one more bad joke.
I may have to edit my slide deck in a hurry. Okay. What is lean? Lean is a method to maximize customer value while minimizing waste. And the key thing is maximize customer value. Value is determined from the customer. You may actually have an external customer who's paying you for something. You can also have internal customers, such as the IT group in relation to development, QA in relation to IT, database systems administration in relation to systems administration, and minimizing waste. We'll discuss exactly what wastes are in a future slide. Various studies basically show things like 15% of what you actually do adds value in a process. So that means the other 85% is waste. 50% of costs in some service environments are due to waste. They don't need to be there. And value is basically a change in form, fitness, or function, or a required pre-step to make one of those changes to the thing that you're working on. And we'll discuss some of that later on in the later slides. Now, Six Sigma, as we're going to address it here, it's a data-driven method to improve quality and value by removing defects. Defects are a form of waste. There is no situation under which a defect can be considered useful. Now, Six Sigma is also a management philosophy, sometimes called management by fact. Basically, it's data-driven. In a Six Sigma environment, you'll have 3.4 defects per million chances to make a mistake. Now, a lot of problems in Six Sigma can actually be handled using the tools without actually getting into heavy statistics. The math that you actually had by the time you reached high school should be sufficient to do a lot of what you need to do in Six Sigma, at least to a first pass. Now, to answer Peter's question about Six Sigma actually being, some subset of 3.4 defects, where does this 3.4 defects come from? 3.4 defects, if you work it out, turns out to actually be like 4.5 sigma away from your midline, somewhere in that range. Here's the joke. When you take measurements, you're measuring over a very short interval. Basically, you're getting a local effect of a process that can go on infinitely. The 3.4 defect at 6 sigma level. 6 sigma is what you have to have your local effect be in order to get a long-term effect of 3.4 defects per million opportunities. So it's basically a time scale shift, also as a 1.5 sigma shift. And that's the difference between the two, and why if you actually know your sigmas, this 3.4 doesn't make any sense. It's got to be smaller. What it is you're actually looking at the long-term average, so you're not tampering with the process every single time you turn around. This is a heuristic. It was done by the people who developed Six Sigma because they realized once they were getting longer-term data, things weren't working out right. So it's your fudge factor, okay? Accept it as that, learn to live with it, learn to love fudge, and move on. Does that answer your question, Peter?
Yeah, kind of.
Yeah, exactly.
Afterwards, but
Yeah,
I kind of get the idea.
Yep. Okay. Now, I was talking with Bill the other day, via seance.com, and was talking about this talk. And he shot me, he's great with the pithy one-liners. So he shot me this one. And I have a sort of an interesting take on this. I think intrinsically everyone knows when their time is being wasted. I think it's just a basic fact. Now, whether you consciously know it or not, it's still there, and you realize it. This leads to discontent. It leads to lack of attention, which leads actually to more errors, which is a positive feedback loop, which you actually don't want. Well, a story from many years ago. We once got dispatched to a gentleman with foot pain at 2 o'clock in the morning. It woke me up out of a sound sleep. I was not a happy camper. So we get there, and we find this gentleman sitting on the stoop with his suitcase for the hospital already packed. His toe, big toe, had been hurting him for 2 weeks. And at 2 o'clock in the morning, it got bad enough that he thought he needed to call an ambulance, rather than waiting 6 hours to call a cab. I am not proud to say this, but I did not give him my highest quality treatment. Now, 6 o'clock that morning, we got a call for a gentleman feeling ill. Actually, 6:30-ish that morning. We get there, finding this gentleman sort of leaning over, barely able to catch his breath, looking like he was just soaked by a garden hose, and saying he felt like an elephant was sitting on his chest. Yeah, that one wasn't a waste of time. Now, what happens when you have all this stuff going on? The more errors, the positive feedback, you get higher turnover in your company. People don't want to work there. People talk. You have to raise your rates in order to get quality people to come in and work for you. And basically, the fewer new people and the fewer good people you get, again, things spiral down. It's a positive, well, negative, I guess, reinforcement loop that's self-perpetuating. Now, a lot of what we're going to be talking about is building the system right. However, one of the things you have to be sure of is that you're actually building the right system. Does something actually need a process? Is the output actually valuable and useful? If not, eliminate it. Don't do it. Back a decade and a half ago at this point, talking with someone who was in charge of a Six Sigma operation to deal with errors that they were having in a paper form version. So basically, you did a whole bunch of stuff on the computer that was transferred to a paper form, and the paper form was sent around to people to sign, incurring delay, and everything is, gotten people at the bottom of people's inbox. It took 2 days to sign it and pass it on. And this was becoming a problem. It's like, speed this up. Well, the first question he asked was, well, why are we doing this? And the answer was, well, this is the way we've always done it. So why have we always done it this way? Well, because we got regulations that require it. Why? What are the regulations? And this kept on going on for a while. And the story that came out by one of the old people at the company that was responsible for the original removal of the paper forms and putting everything into computers was there was an old regulation that actually required physical signatures on the paperwork in order for this particular process to progress forward. It was required by federal government regulatory type stuff. Well, that had gotten removed about 8 years before, but no one quite realized it. So rather than actually doing this whole Six Sigma thing to improve the process and everything, he said, well, just get rid of it. Stop doing it. Stop wasting money printing the forms. Stop delaying things by having things sit in people's inboxes. You get rid of all the errors right up front because you don't have the forms anymore to have the errors. And the computers can double check the information that's entered in the first place. Second story. IT got a request to implement a new service because finance needed some new information from their systems. And finance had this detailed spec about what they needed and all the rest of this. And IT goes off and says, okay, we can do this, and creates this all singing, all dancing ETL thing, extract, load it into another database, put a nice little web front end on it. People get to play a little bit with what wasn't termed at the time Ajax, but was Ajax. Well, they get to the end of this whole multi-month process with, 7-figure costing and all the rest of this stuff. And one of their requirements for their process was, what is this going to cost us per year to maintain? Well, there have been some changeovers in personnel of the group. So the group that initially did the assessments and whatnot wasn't on the group that did the end assessment. And one of the people in the end assessment said, wait a second, you already use SAP and Oracle. Don't they have something that will do this? $250,000 later, they had the SAP module in there. They were already paying support for SAP. This thing basically added no cost whatsoever. It was basically free. Fortunately, that company was smart enough not to fall afoul of this sunk cost fallacy, which is, we paid so much money to use this, therefore we must use it. That's sunk cost. That's built under the bridge, to fix my metaphors. That was not meant as a joke. Just, So what they basically did is they said, yeah, you know what? We're going to scrap all this, all the hardware we have, we're going to put up for other projects to use. We're going to forget about this. We're going to forget we ever did it, which is kind of a problem because I'm willing to bet they had more projects like that because they forgot they ever did it. Swept them for card it. But nonetheless, they came up with a better solution that provided exactly what they needed without a lot of ongoing costs they needed. They freed up surplus resources to win. One of the big problems is if you actually expend effort improving a process that doesn't need to exist, you've actually made things worse. Because you've spent money improving something that doesn't need to be there at all. You've actually put yourself further behind the 8 ball. Does anybody, okay. W. Edwards Deming. Again, we saw his name earlier with respect to statistics and things like this. Quite a smart guy. I think that basically says all of it. Now, one of the key things in this story was people had to ask the right questions. Why are we doing it this way? What value are we getting from this? And most importantly, who's the accountable person? If you find the accountable person, they're the person who can actually make the changes and get things done. Because they're responsible and accountable to other people for the process, and it's their job that's on the line. Now, unfortunately, I've been in a few places where this seems to be the order of the day. I was actually at one company where we had a customer that was very angry at us because of something. And the micromanaging boss of a boss of a boss was running this because it had gotten up to that level of visibility. And one of the people there actually asked a question. I'm going, yeah, that's actually a key question because we don't know which track of solutions to go down. That's like the first question we've got to answer before we can figure out, what the answer is going to be. And basically the manager that was running it gave an equivalent of, we don't want questions, we want answers. If this has been your experience at your current company, okay, still a punchline, but all right. I suggest A, you put track shoes under your desk, and B, there you go. No, you put your track shoes on as you run away. You carry your regular shoes with you. Yeah.
Basically have a bug out bag.
Basically have a bug out bag. You got it, yeah. Now the thing is, this may be salvageable. It may actually be that you've got a middle manager that's totally clueless, and you've got higher level managers that can go and say, yeah, you do that again, you're fired. And I actually do you know a couple of companies where that sort of thing has happened. But I claim they're few and far between. Generally, if you've got middle managers that rise to that level and are that clueless, the people above them put them in that position and are equally as clueless. How many people here know what a knowledge worker is? Few people. Okay, about better than half the room. Peter Drucker. That was my next question. Who brought it up? Peter Drucker. Peter Drucker was a management consultant. A lot of people consider him to be sort of the man who invented management. Yes?
Was that
It may very well have been. There's a book in the 1950s. I still sort of vaguely remember the time when he came up with that information, that term. He coined that term. But basically, he was basically a management consultant. From everything I've read, an extremely, extremely smart man. However, he used a technique where basically he was he would ask questions. And if he's the smartest man in the room, because obviously he wouldn't hire as a management consultant to advise managers if he didn't know more than the managers. Right? He's not afraid to ask questions and appear ignorant. So why should we? If you want smart answers, you've got to ask smart questions. You've got to train your people on how to do that. And that's the way you improve the process. Well, the question is, why do you want to improve the process? We already discussed the effect that waste has on employee morale and retention and all the rest of that stuff. So if that's not sufficient, then how about the fact that you've got other competitors that either have better processes than yours, or they're going to eat your lunch as soon as the economy starts getting tight, or they're improving their processes and they're going to bypass you because they've got a process improvement culture. You basically don't want to be this guy. If you actually think you're too busy doing stuff, rather than, basically if you're working harder rather than working smarter, you've got a problem. You've got to figure out a way to address it. Now my guess is originally they started off with a cart with round wheels, but the guy in front of it dropped the cart and got run over because the round wheels still let the cart run over him. So some smart expert came up with, oh, we put square wheels on the cart and it won't run over the person. Yeah, there's probably an easier way to do that, like a dead man brake or something else that doesn't incur all this process overhead of having to double your workforce just to do a task that one person could have done originally. Now, I have heard over and over and over again, people complain and managers say, you know, I had this problem 3 months ago. It's still happening. I don't understand why. It's cost us X number of thousands of dollars last time, and it's a place to do it again. And when I ask, well, what did you do to fix it? He said, well, nothing really. It's like, really? Did you somehow magically think that things are going to get better simply because you're getting practice at doing the wrong thing? That's going to make it better somehow? I don't have a name for this. Does anybody recognize this?
Insanity.
Bingo, insanity. But it's amazing how many people fall for this. It just boggles the mind. It's totally insane. Now the funny part is developers get this. A lot of the agile methodologies actually come out of Lean. How many people here have heard of Kanban? Okay, it's basically a way of managing flow through the system, straight out of Lean. Kanban cards, all the rest of that stuff. If you read any book on the Toyota production system, you'll see it. How many people here do Scrum or have people that do Scrum? Okay, have you heard velocity in Scrum? The equivalent in lean is takt time. It's sort of 1 over the velocity. It's the number of events you must, it's the number of processes you must complete at each stage in order to keep up with customer demand. In Scrum, velocity is the number of things we can put through the system in a given period of time. So they're related concepts. Now, what do you need in order to actually be able to pull this off? Management support. That usually is seen in the case of no process jumpers. If a process is in place, everyone goes through it, even the manager who's accountable for it. If he doesn't like it, it's in his power to correct it for everyone. The boss doesn't jump the process. One of my coworkers told me that, be patient, John, things will change when there's enough pain. I've been absolutely amazed by the ability of coworkers to accept pain. I really have. I think I will be old and dead by the time they have accepted enough pain to actually change things, where I will have run screaming away in pain earlier. You really do need the recognition sort of across the board that doing things as they are isn't sustainable. It doesn't really work. Experts. Yeah, experts. Experts should be able to say, I don't know, and not get gigged for it. One company I was at, we had a customer who was very upset with the way our software was performing. We had an expert developer who said, oh, I know, it's this process right, it's this subroutine right here, it's horrible, it's got, you know, and it's linear in n when it should be square root, or it's like quadratic in n where it should be, you know, whatever. So he goes off for a month and rewrites it and does some test cases, says, oh, look, I got a 90% improvement in speed from my 2 test runs. Well, we put it in the customer site, and the customer goes, this is still logic. So the Oracle DBA expert we had, who actually wasn't being used as an Oracle DBA expert, but that's another story, we actually sat down and tried instrumenting the code. Sure enough, that routine really was horrible. And it accounted for 2% of the runtime that we were seeing. So even if he totally eliminated the lag of it, we would have still been 98% in the hole. It turns out there were 2 routines that were both hitting the database that consumed most of the time. And the people asked the DBA, they said, well, what's the fix? He said, I don't know. I've got to find out. I've got to instrument this and see exactly what path it's taking inside of Oracle to figure out what's wrong and to figure out how to solve this. In other words, I need data. The expert that always seems to know exactly what's happening and exactly the right fix is an expert who needs to fear. The people that don't know much are always certain. The people that really know their stuff are always uncertain.
Are you sure about
Not really. No, I'm not. I'm not really.
that? The quantum physicist knows.
Yep, the quantum physicist does not know where that particle is or how fast it's going. Accountability. Yeah, well, they know one or the other. They don't know both.
But they can tell you for sure what the error is.
Exactly. Exactly. They tell you how certain they are about it. Accountability. If you don't hold people accountable, things don't get fixed. If you're a manager and one of your subordinates produces absolute garbage that makes it into production, but then requires a 2-week effort by your top developers to fix, and you don't get gigged for it, there's no penalty for it. There's actually no impetus whatsoever for you to correct how you're doing things or not doing things, as the case may be. Accountability is required. Now, to go along with that is process culture. I once interviewed for GE, a division actually that was down in Florida. Of the 5 people I interviewed with, all of them, GE is big on Six Sigma. This was in the 2000s. I was interviewing with them, so I figured, it certainly would have made it over here. 2 of the 5 people knew Six Sigma, knew it inside and out. I had very interesting conversations with them about it, and they admitted that since they had moved to that division in the operations group, they had not used it. The other 3 people had sort of a passing familiarity. They recognized some of the terms. They couldn't really tell me about it. They couldn't tell me the definition of Six Sigma really. Well, my last interview of the night was with one of the managers, and what he explained to me, he explained this discrepancy. It turns out that group had grown by acquisition. The two people I talked to that knew Six Sigma through and through were actual GE employees before they moved to that division. The three people I talked to that weren't familiar with it were bought by acquisition. They didn't have the process culture. Now, this also points to a failing on GE's part to properly indoctrinate these people. But, you know, this is the sort of thing where everyone knows what's happening. Process improvement is everyone's job. From the person at the very bottom to the person at the very top, this is what they think about and consider as they go about their daily duties. Yes?
Since you brought up the term indoctrination, we may talk about this later. What keeps process from turning into dogma?
Constant review. We will discuss that. We will discuss that. But it's basically constant review. It's constantly asking why. Why are we doing this? What value does this add? It is quite possible that process that occurred at one point no longer has any value. And if you simply let it sit there and fester, it will keep on getting baggage. And then you end up with processes dogma. Why are you doing it that way? Well, we've always done it that way. And there's your processes dogma. The last one is a don't shoot the messenger. One company I was at, we actually had an intern, summer intern, who brought up a very important question as to why a problem wasn't caught earlier on. It had made it through multiple checks and everything. And he said, well, you know, it should have been caught up here, shouldn't it? I mean, this test is supposed to do that. So the company vice president says, you're absolutely right. I want you to work on doing that. Solve that problem. Okay. A, intern, gone in another month and a half. B, has no accountability for the process whatsoever. C, doesn't have the contacts within the company with the people that are required to work on it and work with it to influence anything. That is a typical case of shoot the messenger. Now, should he certainly been involved? No, I would have hoped the manager would say, you're absolutely right. Steve, you're the accountable person on this process. We need to fix it and make sure this stuff doesn't get through again. Would you, Mr. Intern, like to be part of that process for the length of time you remain at the company? That would have been an appropriate response in my book. Putting the intern and making him responsible for solving this problem? Sorry, no, absolutely not. Again, another quote from Deming. Badgering individuals to do better doesn't work. It lasts maybe a week, perhaps two. Unless, of course, you hook them up to IVs full of caffeine, in which case you might get a little bit of extra longevity out of it. The role of management is to improve the process to account for the people that are working the process. And if management abdicates that responsibility, well, frankly, that's the only reason they exist, because they're the only ones that can often control this, because they're the only ones that are accountable for the process. Process improvement really is a process. First thing you do is tame the process. That is, make it repeatable. Everyone does it exactly the same way. Then you make a change. Is it made it better? Has it made it worse? If it's made it better, put that back into the change process. Once you've got all of the best practices that you found everywhere else that you can test, then you go on and you perfect the process. You try things that are outside of that, the new best practices that you can develop, rather than the best practices you're pulling in from your competitors and friends and all the rest of that. For anyone who's ever worked with Program Management Maturity Index, PMMI, or has ever worked with the Capability Model Maturity Index, you'll see a similar concept in their levels, level 1, 2, 3, 4, 5, however many each one of them has. Did you have a question? Okay. But this is certainly a process. Huh? Yes?
Does rapid prototyping come into this?
I could certainly see that having an effect. You're really more, that would be a tool that you would use to validate some of your claims. If you're trying to figure out 2 or 3 different ways to do something, you might do a rapid prototype to get sort of spend 20% of the effort, get 80% of the buck, and see if it's a feasible thing to consider running as a test to improve the process.
So that thing.
So exactly, so it'd be part of a tight feedback loop. Exactly, it'd be part of the feedback loop. Okay, hopefully I've given you some idea about why I think this is important and what I think is valuable here. We're going to have a bunch of terms. I'm going to cover most of these in the following slides. First thing we're going to start with is 7 wastes. I added an extra one in here, as some other people do. The acronym for this is Tim Wood. The first waste that was identified is transport. Transport waste basically occurs when you move things between steps in a process. Think about putting a computer on the computer room floor. It arrives in the loading dock. It's moved to staging room A. It's moved to staging room B. It's moved to the floor. It's finally unpacked and repositioned. The moves to staging room A and staging room B are totally worthless. They had no value whatsoever. You're just shifting inventory around. It needs to go away. Move it directly to the floor. Have your space already set up for it. Get you uncrated. Next is inventory. And inventory is one of the things that Kanban actually tries to handle. Work in progress. How many people have backlogs of open tickets? That's work in progress. The longer it takes you to get through there, often the longer it takes to get the new ticket in and to get it solved, because that's a load on your system. You've heard of technical debt in software? Well, inventory is also a debt in process speed. And then you've also got various other forms of it that I touch on somewhat later. Next thing is motion. Motion and transport are actually a lot alike, except motion is sort of defined to be within a process. So, for example, if you're entering a new employee, on screen A you may enter a whole bunch of information. You have to shop over to screen B. You may have to go to system C to enter some more information to come back to screen B. All of those changes, all of those transfers are motion within a process. I've actually had people get involved in the discussion about whether a particular step in a process is transport or motion. It doesn't actually matter. They're both waste. You need to get rid of them regardless of which it is. Categorizing it doesn't really affect the fact that it's still waste. So actually arguing about whether it's transport or motion waste is, well, kind of a waste. Waiting. How many people have put in their what do you call it? Your travel and expense reports, and then 2 weeks later, the money finally arrives in your checking account?
2 weeks? Wow, that's nuts.
Okay.
I'm still waiting a month out.
Yep, exactly. Why? You're waiting. It sits in somebody's queue somewhere, stacked up in their inventory. It gets moved to somebody else's queue, waiting for a signature. It gets moved back. All of this waiting and just sitting there is, again, another one of the wastes. Overproduction. My favorite one about this, as everyone knows, I'm big into log analysis and real-time log analysis. People seem to like turning on all the logs you could possibly get from the firewall. I really don't care if somebody was probing port 197. You get all this stuff, they don't know what to do with it. It basically stacks up in your analysis system, delaying your ability to actually process the alarms and log messages that matter. And then you've got to store it on disk as inventory. If you're not going to use it, don't produce it. Yes?
I would argue, I mean, I guess that's the case that, you know, you can think of it more as fatigue more than
Yeah, exactly. I mean, you also have fatigue that goes...
Because there can be cases where you know.
Oh, yes, if you have a plan to actually use that data, then it's not overproduction. Yeah, if you're actually using that data, and you're going to rules as if from kernel and deny, drop.
Sure, I guess my greater point is that they're more fatigue.
Right, yeah.
Are you going to actually know what to do?
Exactly, exactly. It is very much a fatigue issue as well.
There is one problem with that, another problem with that example, is distinguishing overproduction from foresight is something you can only do in retrospect.
That's true, but the thing is, I found that when people collect that much data, even when they're penetrated, A, they don't always realize it, and B, they've got such a flood of data, they can't make any sense out of it anyway, even after they're penetrated. Yeah, you may be able to pay someone else to make sense out of it. That is true.
That's part of your process.
But that would be part of your process from the get-go, exactly, and you would have had a plan about what to do with it.
Oh,
Certainly when we are running internal firewalls, firewall drops would warn us we had a very, very low signal-to-noise ratio, as opposed to an external box that gets, signal-to-noise ratios through the roof. Overprocessing. This is sort of one of the things that a lot of the agile methods put off. Don't build the cart before you build the horse. Make your decisions as late as possible. Don't add more functionality than you need to be able to easily foresee. Defects. Like I said, there's no defect that's a good defect. Period. Last one is skills. Using a third level help desk technician to solve a problem that a first level should be able to solve, because nobody bothered writing a run chart to say, check this, check this, check this. That's a waste of skills. Having somebody log into 7 different systems to accomplish their job rather than using a single configuration management system that handles all of that, and having to put up with all that motion and waste is a waste of skills. Using people in roles to which, I was hired as a system administrator and congratulations, I get to sweep floors. Again, a waste of skills. Now, one of the ways that you can often see, especially the motion waste, is called a spaghetti diagram, which is basically a diagram of moving back and forth between all the places you have to move to. On a shop floor, it often looks like a bowl of spaghetti as all the lines crisscross all over each other, hence the name spaghetti diagram. So one of the ways that you can also see waste in motion and things like that, especially waste in waiting, is called a RACI diagram. This says who is the 4 ables, who is responsible for something, who's accountable for something, who's consultable for something, and who's informable. Very often you'll have people that are in the responsible category for actually doing something that don't really need to do anything. They haven't actually added any value to the system at all, and they're just there for legacy purposes. Going back again to your dogma process question. One company I know of, they basically lopped off 7 signatures on something because none of the 7 people that had to co-sign the information ever turned down the program manager's request for money. He was accountable for it. These other people weren't. All they had to do was sign off on it for some reason. So that meant that rather than taking over 2 weeks to get money to be able to pay something, it was a 1-day deal. You talk to the program manager, he signed off on it, that was all that was necessary. 5S. This is a typical one of Lean. It's one I actually have a few problems with applying to an IT environment. The basic idea, and you'll see how this applies to a workstation or even your desk, sort. The idea is you take everything that you've got in your immediate work area and you tag it and you say, okay, I need this to do my job, or this is sort of migrated here and I don't really need it to do my job. Often they'll put a red tag on it, and every time they use it, they'll label it. Then they'll go to the straighten phase and say, anything in here that hasn't been, that's red tagged, that hasn't been used in the last month, let's put it somewhere else. Put it back in the tool bin. Put it back in the library. Put it back somewhere where I can get it again if I need it, but I don't need it immediately accessible with my fingers. Shine. Make sure that the manuals and things I'm using don't have torn pages, aren't missing data. Basically, it's the quality of the tools that you're using you keep up to date. You keep them maintained. Standardize. Everybody does everything the same way. So I can go from one station for doing X to another station for doing X and still be able to do my job. Typical example, laptops. A lot of laptops are totally interchangeable. Your laptop breaks, you can get a new laptop built almost immediately. Phones. I'm sure that as soon as you get a new phone, you'll connect to Google Cloud, get all your contacts and everything back on it, and you'll be up and operational almost immediately. Okay, slow Wi-Fi, obviously. And sustain is basically going back and doing it again. Standardize, typical example of that is configuration management systems. That's their role, is to standardize the layouts of multiple systems across things. So while there are ideas from 5S that are applicable in IT, the techniques are extremely different, and the way you have to think about it is kind of different. This is one of those areas where there's more of a disconnect between Lean. But basically, the whole idea is you get rid of errors by removing distractions. How many people have actually logged into a service they thought was running a service, found a perfectly good config file that's there, changed the config file, went back to test, and found out it made no change whatsoever? Few people. How many people later found out that that service had actually been decommissioned there and the file was actually abandoned in place rather than being properly cleaned up? Again, sort, straight. So like I said, the analogous ideas are there. Now, the one other thing we're going to talk about as we close out the lean segment is value stream mapping. Six Sigma has a concept called process map, where basically you go through the entire process from start to end, and you write down everything that happens. Basically, the same mechanism is used for value stream mapping. Go to the site, the Gemba. Yes? No, maybe? Close enough. Okay, Gemba. Basically, go to actually where the work is being done. And when you're there, and in Toyota, they actually draw a circle on the floor, and the manager actually stands there and watches the process as it goes through. See how it's actually done, not how it's done in theory. Don't bother pulling your ISO 9000 volume off the shelf. It doesn't actually correspond to reality. It's a lovely fictional book, although the characters are somewhat dry. But you actually need to go and see how it's done in practice. Because as we all know, in theory, practice and theory are the same. In practice, not so much. Now, when you look at the process is seen by the customer. The process from the customer, we start with the email requesting a new laptop. If the help desk's idea of the process starting is once the customer has specified the size of the disk needed in the laptop, the screen size of the laptop, how much memory is in the laptop, and the manufacturer and model number, you've got a mismatch there. It's always the customer that wins. The customer said, I sent a request for a new laptop. You shouldn't be sitting there waiting for me to specify this stuff. You should be helping me get this information. That becomes part of the process as seen by the customer. Also, as you go through the sequence, try going backwards. There's something called SIPOC, which is suppliers, inputs, process, outputs, customer. Try going backwards through it, looking at it from the customer end and what has to occur to make everything work for the desired product for the customer. For any of you who have ever had to go and edit your own work, reading sentences backwards is actually an interesting way of doing it, because you actually discover things like double ands you don't see when you're reading it forward. Yes?
You have a question at the help desk. You're the help desk. Why don't you already know what kind of laptop I have that I need to list?
Exactly.
Versus when I call the Hyatt to fix a reservation for 3 weeks from now, they don't even ask my name. They have my caller ID. They know exactly who I am and what reservation options I'm playing. As opposed to having to repeat my information 6 times over like AT&T.
Hyatt, Hilton, those are companies that are very much, I don't know if they still use Six Sigma, they're very process-oriented. I mean, the location of the mint on your pillows, from what I understand, is actually a specified thing that they train people in. Sorry?
I start seeing contrary.
But categorize each step. Once you've figured out what the process is, each step is either adds value, it's required non-value, or it's waste. Required non-value is sometimes required by regulatory conditions. It's sometimes required because somebody else isn't doing their job, and you're catching their failure. So there's a number of reasons for required non-value add. The idea is you minimize the amount of time spent adding value, you minimize the amount of time in required non-value add or remove it entirely, and waste should just go away. And all of this is as turned by the customer's point of view. One thing that often happens, though, is value stream is done in a small area. So while it's optimized here, for the customer and for the supplier, it's often not. You're often forcing them to do things to make up for deficiencies in your process. So if you're in the middle of a company, you really need a wider view of what's happening to make sure that you're not locally optimizing and globally unoptimizing. Now, what I did for this was I took one ticket that I had, and I went through and did a value stream map on it. What I want you to notice here, the dark blue is where I actually added value. This was value that was added, but no human was required. This is required non-value add. We'll discuss that in a little bit. All the red, however, waste. And note, the loading data, this is actually an 8-hour section of a 24-hour day, so the loading data phase actually finished somewhere off the chart in day 2. It continued overnight. I didn't have to babysit it. So what does this tell us? Total cycle time was 35 business hours. Value add was about 14 hours, of which about 1 hour was spent with an actual human adding value. We wasted 13 hours. We could have had this system deployed and delighting the customer a day and a half earlier. If only we hadn't had to waste time with that. And this doesn't include the 8 hours of required non-value add. We've got that soak time in there between the deployment of our backup data center and our primary data center. If I could have gotten rid of that, this whole 35 business hours could have been reduced to 8. It could have been done in a single day and been out there delighting the customer and let the developer go on to the next thing that they wanted to develop to delight the customer. Why do we have required non-value add in this process, you might ask? Well, actually, I forgot one thing. It's actually worse. Between development and us, we had a bunch of handoffs. Each handoff basically was a half hour wasted. So we actually had at least 2 hours of additional time from the record on the ticket that was spent doing context shifting. And I think there was actually more than that. I'm almost positive there's more than that. I just can't prove it by looking at the ticket. So the question is, why do we have the required non-value add? Well, this is why. Yeah. Even though she's cute, it's bad. So we have the required non-value add because of inefficiencies further up in the process. Now, how do we identify problems? The easiest way is when you look at the failure, you train your people to group it into categories. Count up the number of instances of failure. And some failures can actually be in multiple categories. You can have multiple causes of failure. Count up the instances or count up the cost. For instance, I just plugged this system into the power jack and it fried the whole system. Well, there's $1.5 million computer down the tubes. So, okay, let's see, for $795, a Radio Shack volt ohm meter to make sure the fly-by-night electricians actually wired the plug up right. Seems like cheap insurance to me. There's many ways you can actually determine the cost, whether instances, real physical dollars, hours spent. And then what you want to do is determine the significant few from the insignificant many. And the way we do that is to use a special bar chart called a Pareto chart. Basically, categories along the bottom, whatever your measurement metric is in the vertical. In this case, I'm using counts, and there's 28 items totaled up. What you're looking for, since this is 10 out of a total of 28, it's a little bit above a third. So what this yellow line is the cumulative percentage that change accounted for. So this guy's a third. Here we're just about half, roughly 60%, because we've got roughly 8 and 10, 18 out of 28 counts. And what we do is we go up to 80. We say, okay, anything below this 80 cutoff line, we're not going to deal with. I don't care how much your expert says that the SQL stuff is screwed up and needs a total rewrite. It's down the insignificant many. We're not going to deal with it. That's not where your problem lies. This actually uses the 80-20 rule, also known as the Pareto rule. It shows up in a lot of places. 80% of your profits from 20% of your customers. 20% of your effort gets you 80% to where you want to be. It's really funny how it shows up.
80% of your work is done by 20% of your employees.
Yep. Yep. Now, in many cases, what you might do, if I was doing this guy, I might take these bugs and subcategorize them and do another Pareto chart just of the bug category and see what my biggest failures were there. Yes?
Just looking at it, I would say install docs, no package, big bad, other might fall under failures in use of configuration management.
This is actually a handoff. So no package was actually, the package hadn't been promoted to the appropriate repository.
So with the common cause.
Yes, exactly. You could have a common cause. You could have a common cause.
In which case that graph gets changed around that.
It does. You have to be somewhat careful at choosing, your categories are context sensitive. You have to know the context in which you're doing the evaluation. So the install docs, the no package doesn't actually fall under a configuration management system because it's before it ever really hits that. It certainly is release engineering issues, without question. Release engineering is a problem here. For all of these guys, definitely fall under a release engineering rubric. Yes?
At least in my limited experience, if distribution is the limited turning up, the bars,
Mhm.
power distribution,
Mhm.
then video analysis is really
Yep. Yeah, exactly.
If you have very few items, it's almost like
Yeah, if you have very few items, generally, I've seen people like to have between 7 and 10 categories. I've seen people go down to 5 to 10 categories. And then do a sub-analysis on that.
Yeah.
And then do a sub-analysis on that to get the really key view. But yeah, and the thing is the power law actually shows up in a lot of stuff like this simply because of the nature of the faults. You'll often see either a Poisson or a Weibull distribution to the failures.
okay.
And hence exactly what you're saying.
Right.
Okay, so this has now told us where we need to look. The question is, how are we going to find the root cause? The root cause is somewhat of a bogus thing. There usually is not one failure. It's usually a series of cascading failures, all of which had to fail to actually cause the problem. But we're going to discuss 5 whys and Ishikawa diagrams. The 5 whys basically is you have a problem, you ask why it happened. Then, when somebody gives you an answer, you ask why again. And you repeat this 5 times. If you stop at 3, chances are you're still sitting on a symptom. So repairing the symptom doesn't actually solve the problem. Your problem is still lurking down here, which you would have discovered if you kept on going. Some places never get past the first why, usually because the expert says, oh, I know why, and he goes off and doesn't fix it. The other typical example you get is called a cause and effect diagram. It's also known as an Ishikawa diagram or a fishbone diagram. So called because it actually looks like the bones of a fish by the time you finish doing it. Now, I think we got just enough time to give you an idea on how this works. If those of you watching on the network, I'm sorry, but this is actually a blackboard exercise. The way you put together a fishbone diagram is you write the problem on the left-hand side, and then you draw a backbone. And then you categorize off the backbone. These categories sort of depend on the problem space you're talking about. For manufacturing, it's usually the 6 M's, where people is called manpower and environment is called Mother Nature. For services, you've got the 5 S's. For some stuff, you've got the 4 P's. Find something that works for you. Here's our problem. Warm iced coffee. Particularly appropriate at the moment, absolutely infuriating. Somebody give me a reason why I might get a cup of warm iced coffee.
No ice.
No ice. That sounds like a material problem. Why would I not have any ice?
No electricity.
It's broken.
Refrigeration has done it.
Electricity? Refrigeration broken. Okay? Give me another reason.
Mismanaged expectations.
Okay, mismanaged expectations. I would go with probably method on that.
It's warmer than you expect.
Or we don't actually sell warm iced coffee, but somehow people do.
I call it coffee.
Right? And as far as warmer than you expect, I'd say that probably goes under environment. Why is it warmer than we expect?
Global warming.
Well, global warming.
The automatic iced coffee machine is heat pump.
Yep, the automatic iced coffee machine. So again, that falls under machines.
So would coffee too hot to begin with fall under that?
Yep.
Somebody didn't.
Actually, that would probably fall under measurement to tell you the truth.
Somebody didn't push the right button. Lukewarm coffee instead of.
That would probably be under method.
That's not a people.
What is it?
Nobody to get to the warm ice, the ice coffee turn warm.
Bingo.
You're the 83rd person to get iced coffee, and by the way, we were out of ice at 64.
Exactly. That goes back to material, no ice. Right? So you see how this works. So why do you have no people to give you the coffee? Fire, staffing, this schedule. This schedule of people, right?
Or training of
Grinder.
Exactly. So you see how this basically builds up. You use your 5 whys from each one of them to expand out, and this is basically how you build it. Now, once you've got this, you'll use one of a few different techniques to decide which of these are most likely. A lot of them, you'll often assign measurements to say, hey, well, for measurement, is the coffee too hot? Well, let's stick a thermometer that's properly calibrated in it and run the thing through a cycle and see, was it too hot? Are we producing 150-degree coffee when the spec calls for 100-degree coffee? Or some such like that. So this is basically how you build it. And then from there, you'll isolate causes. You'll try to figure out what measurements you need in order to cut off information or problems. And that's basically the effect. Now, some people have a problem with the Ishikawa diagrams. First of all, apparently going left to right is a problem for people. I don't understand why. It's like right to left. Huh?
It's perfectly normal Japanese writing.
Exactly. Well, that's the thing. It's Ishikawa, so the language goes right to left. So it's
And
perfectly
people from Israel love it. So
exactly. I think fish's head should always be at the right. Exactly. And you're working it backwards. I don't have a problem with it, but there are some people that do. There's something called cause mapping as well. That's an alternate way of doing it. What cause mapping basically does, it does away with having to categorize things. You may have noticed I wasn't necessarily sure what category to put stuff in. So cause mapping is sort of more free-form. It lets you take your causes and sort of move them together to associate them into affinities. It lets you do linkages between them so that A and cause, this cause actually has 2 linked causes. So cause A and cause B has to occur. You could represent that on the diagram. You can also go both right to left and left to right so that you can link it to actual goals of the business on one side if you're trying to justify this to your management colleagues as to why this is a problem. So it's a different way of doing it. I actually do have a slide for it, but it's not. I didn't include it in this deck because I figured we'd be running long, and sure enough, we are. So the next thing I'm going to do is talk about DMAIC and PDCA. PDCA we discussed a little bit when we discussed Deming. This was his method for doing process improvement. But DMAIC basically means define. Very first step. What is the problem you're trying to solve, and what other things do you need in order to be able to solve it? Next thing is measurement. What do we measure? How accurate are our measurements? And all the things associated with actually being able to turn measurements into data rather than garbage in, garbage out. Analyze. Take the results of our measurement, use an Ishikawa diagram, use a root cause diagram, use some of the other tools to figure out what the actual problem is. What do we want to solve? Once we've done that, we try to improve it. When we improve, we redo our measurements. We check to see, has this actually fixed itself? Or actually, has it fixed itself? Has it been fixed by our improvements? How do we control this to make sure that we keep the correct thing happening? And if it hasn't, because it only occurred by chance, we have to go back into the analyze phase and try again. We have to change another input to see if that affects our outputs. Deming had PDCA, which is very similar. Plan the change, analyze and predict the results. Very similar to the define and part of the measure. Do the plan taking small steps in controlled circumstances. Are the measure and analyze steps, and also improve. Check. Check the results that you got after the improvement. Then act. Take actions to standardize and improve the process permanently. So again, similar idea, just different take. Define. The deliverables from here are a problem statement. What is actually wrong? Identifying the things that are critical to quality from the customer viewpoint. What does success look like? How do we know when we're done? What are the constraints on my solution? What can I absolutely not do? No, I cannot take the customer and put an atomic bomb underneath their building to get rid of the problem. Measurements. We can try, but again, they have a tendency to frown on that. Measurements. How? Exactly. Yeah, there's a whole payment issue as well. Exactly. Measurements. How do we know that we actually have a problem? Is there something repeatable that we can use to tell us when we've actually solved this? Generate the business case, again, up to management to see if we're actually going to spend effort and time on this. And deployment plan. Is there somebody affected by line improvement that is going to be dead set against it that we have to have on our side in order to make this plan work? Then, between every one of these steps, we've got a toll gate. You basically check after every single step to make sure that you've got all the checklists done for information you want and you haven't left anything out. Assuming we've passed this toll gate, we go on to the measure phase. What do we measure? Can we actually measure what we're interested in, or do we have to find something that's associated with it or correlated with it that we can actually measure? If we do, what sort of effect does that give us for errors? How do we actually do the measurement? Do we take a satisfaction thermometer and stick it into our customers to find out how satisfied they are?
Only through it. Only through it.
Oh, yeah, exactly.
Not with the contracted grade, but.
Exactly. Who's going to do the measurements? Usually, who does the measurements is the person actually doing the work. In Toyota, the people doing the measurements are actually people who do the work. And when there's a failure, they pull the big lever that stops the entire assembly line and pulls everyone in to figure out why they're getting bad measurements, why the control charts are out of whack, and how to fix it and make sure it doesn't pass that point. That's a lot of power to give to a line worker, but that's how this sort of stuff works. Quality of measurement. Is the measurement accurate? Is there some standard we say, okay, this part is exactly the same? If the same person does the same measurement over and over again, do they get the same result? If different people measure the same thing, do they agree with their measurements? Is the experiment repeatable by someone else? Sorry, is the experiment reproducible by someone else? And training. Go ahead, measure that temperature. Okay, where do I have to grab the thermostat? Do I grab it at the ball end as I put it in? No, you grab it at the back end of the probe. You must have it a ½ inch into the material. Otherwise, you must not touch the bone of the chicken. Otherwise, your temperature reading will be off and not valid. All of these things you've got to be concerned about in the measurement phase. And again, you'd have another toll gate. Analyze. You've got the data. You now analyze. What does that tell you about the root cause? Remember I said in the Ishikawa diagram, we've got measurements associated with these various things that can tell us what works and what doesn't. If the temperature comes out to be 140 degrees and we're expecting 140 degrees, well, we know that this problem set right here doesn't apply. And we need to look somewhere else. Yes?
Where's the obvious that you measure something?
Yes. That comes as part of the measure. Define what you measure. Consider what it actually tells you. Yep. And also, like I said, when you assign measurements here, that again falls in. You measure what you manage and you manage what you measure. Everything that you are doing is through that measurement. So you've got to make sure you're doing the right measurement. And that definitely comes into the measurement phase. Yes.
An example came out of 3 Mile Island. There was a critical valve, only it had been closed. And all other indicators told them, oh, it's closed.
Mm-hmm.
What that indicator actually told them was that the motor to close the valve was actuated. Right? It didn't tell them whether or not the valve had actually been actuated.
Yeah, it was told to close.
Exactly.
It sends a signal, and the motor is doing something, but we can't actually tell you if it's this way or this way.
Exactly. Now, they had a flow meter right in the line beneath it that said, yeah, I'm seeing 70 gallons per minute going past this valve.
They could solve it within a few hours, not
Exactly.
help.
Exactly. And now all of that comes in the measurement phase. In the analyze, again, you predict your results. If we improve this process, what do we expect to have with this measurement? What does a better measurement for this look like? Then we go on and we improve. We determine what actual changes we need to make. We make the changes. We train the workers. We develop the tools, the forms, and the checklists to make sure this is actually done right. Just a sec here. And then we have to control it. The first question is, the problem really been solved? And if it has, how do we keep these improvements? The control is sort of a tricky problem. Measurements by their nature are variable. If you measure something 3 times, you're not going to get exactly the same measurement each time. There's going to be some error associated with it. So if I take measurements of a process before and after, my question is, has the process actually changed? I've got different measurements. But the question is, does this really indicate that my improvement fixed the problem? Similar to the developer I told you about was absolutely sure this one routine was bad. Well, the problem is there's so much variation in the routine. The fact that you got a 90% improvement in it, A, was somewhat true, but there's also enough variation in there that was totally meaningless. So we have to figure out, does it occur by chance? If so, we have to go back to analyzers. We're actually toggling the wrong switch that's not connected to our outputs that we care about. The next question is the problem solved. In the analyze phase, you'll often end up refining what you had in the define phase for what it means to be a solution. Is the problem solved? If not, again, go back to analyzers, so keep control. Now we come up to lies, damn lies, and statistics. Oh, marketing. Okay, I like the marketing words too, but statistics is the one I was going for.
By the way, to go back to Peter's slide,
Yes.
You fixed it, you found a problem, you fixed it, you found it, you're now doing the correct thing.
Yep.
In doing the correct thing, it is uncovered 3 more problems.
Yep.
At that point, you have to tell the person, it is okay if you've uncovered these problems. It is okay now for us to create work for the 3 people who are now accountable for these problems.
Exactly.
Because if you don't have that support in place, there's a lot of pressure to cover up the problem by reverting your change.
Exactly.
That happens in real-time systems too,
Yeah.
and a lot of aircraft, and a lot of large airlines.
Yeah. One of the things about lean, as you lean out the process and you remove steps that don't matter, you often get decreasing variability, but it also shows where you actually have other problems, because since you decrease the variability, the steps that are left are actually exposed as sources of variability. So you end up having to fix those after you've got rid of some of the original stuff. So as you go down this continual improvement, you keep going through, you keep uncovering new stuff to fix. Now at some point it may not matter. Those other 3 things may produce so little variability that you don't really care. But at that point it becomes a business decision as to what you want to do with it. It's not necessarily always a technical decision. All right, so the question is, do we have a real change or is it due to chance? If we're looking at averages of things, basically arithmetic averages, add up all the values, divide by the number of values. We can use something like a t-test or a Mann-Whitney used statistical test to determine whether or not something's actually changed. If you're looking to see whether your maximum and minimum have changed, there's other tests you can use. F-tests, Levine, some of these have restrictions on them as to how the original data is distributed and the frequencies. So before you do this, consult a statistician or read some statistics books. It's not particularly difficult, I claim. However, it is something you do have to be a little bit careful about. And the other question you've got to ask yourself, do you have GIGO syndrome? Is your data valid? Is it repeatable? Is it reproducible? Is it really meaningful? To go back to your question there. This is where you're going to see it again. Now, how many people here know what a histogram is? Okay, pretty much the entire room. Basically, bar chart, ordered, counts on the vertical axis showing you how often a particular value or set of values occurs. What I did was we close about 140 tickets a month at work that are not initiated by the operations staff. What I do is I chose 20 of them randomly. I counted up the number of interactions where a question was posed to the person opening the ticket. Why? This is a typical indication of how much weight is in the system, and I want to get rid of the amount of weight. I then did this for a second month period. And I have 2 data sets, month 1 and month 2. What I also did is when I went to calculate the month 2 stuff a month afterwards, I went back and redid my evaluation of the month 1 data. Basically, I went to see if I was able to reproduce my standards. And I was sufficiently good. I had 1 mistake in 40, 50-odd interactions. So, here is the data that I came up with. So can somebody, now first thing to note, scales are different. This scale on the left is maximum of 3, the scale on the right is a maximum of 5. Anybody want to make a guess as to whether or not the average number of interactions has actually changed? All of the actual number has changed, raise your hands.
Numbers are so low, it doesn't matter.
Well, actually it does. You actually can make a statistical inference from this. The 20 samples actually is sufficient to do that, I claim. But yeah, the answer is no. There actually is no change here. And if you run the statistical tests that look for this, both of them say you cannot make the claim that the average of this has changed.
And you just want to root in, right? You want to
No, because this is not an average of samples. It's actually the sample data itself. So you don't get the central limit theorem kicking in, which is what you're thinking of signals through then. So basically, in the language of hypothesis testing, I make the claim that I cannot reject the null hypothesis that these are distributions from, these are samples from exactly the same distribution. And I actually expect them to be, because we hadn't fixed anything. These are 2 different months. We were still doing things the same old way. We actually hadn't changed anything. So I wasn't really expecting a big change. Now, an easier way of seeing this information might be in a box plot. Box plots have a median line that's in the middle of the colored section. That 50% of the data points are above it, 50% are below it. The edges of the box have, the bottom edge of the box has 25% of the data points below it. The upper edge of the box has 25% of the data points above it. And just looking at this, I basically see that both of my median lines are sitting within the colored boxes of the other graph. Just at a first glance, it's like, yeah, that median hasn't changed any. Those distributions are the same. So just on the basis of this, I would not expect there to really be a change in that data. And this is a slightly easier way of seeing it. We're going to skip the variation exercises. We're running long. Staying in control. There's 2 things to stay in control. One is to prevent errors, and the other one is when errors occur, please detect them. Now, one of the ways to detect the errors is to basically redo the analysis I just did on a periodic basis. If I've improved things, I expect not to see a change in my median from month to month as I repeat the tests, and I expect not to see a change in the variance. So I can go and do that. There are better ways of doing it, easier ways, and we're going to talk about control charts. But first, before we get there, let's go to preventing errors. Checklists are wonderful things. Their tops are made out of rubber, their bottoms are made, that's Tigers. But checklists are still wonderful things. It reinforces process and helps increase consistency. How many people here have ever taken a CPR class? A, B, C, check the airway, check breathing, check circulation. This is a checklist. It works. It's amazing. Yes?
It's no longer able to see it.
Yeah, I know, but I don't like the way they do that.
It doesn't matter.
Right, it doesn't matter. It's still a checklist, and there's still an order to it.
And when you're on the street, it doesn't matter.
It probably will not. As long as you remember all 3 of them, you're good. Now, surprisingly, checklists are just making their way into the operating room. And there's actually an interesting, a couple of interesting papers showing a decreased incidence of errors, better patient outcomes as a result of doing things like the entire surgical staff here. Okay, this is patient John Smith, right? Okay, we're working on his left knee, and that's his left knee, right? Okay, yes?
You have the lowest ranking person in the operating room.
Yes, that's the other thing. It's the lowest ranking person in the operating room reads the checklist. That way, no one's afraid to contradict them. If it's the surgeon that's doing it, you don't want to be contradicting the surgeon.
By the same token, they also have everyone introduce themselves so that you know how to work with them.
Exactly.
So that you don't have that issue of not wanting to do that.
It certainly helps to prevent that, definitely, without question. Now the other thing, in addition to checklists, are poka-yoke. Okay, poka what? Okay, poka-yoke. Sometimes I've heard people call it idiot-proofing. I dislike that term. The pejorative is really bad, and it's really kind of wrong. It's more mistake-proofing, where it basically check at the point at which you could introduce that mistake. Make sure that mistake doesn't get past that point. Nick's work with continuous integration to check his puppet stuff is along the right idea. I still think that's happening way too late. It should be earlier on in the process. However, okay, exactly. If you're pre-committed as well, that's also great. A lot of the tools you're working with, though, don't really allow an analysis at the time. So what you're doing is perfectly legitimate and really a great idea. Code reviews done right are also part of this. Unit tests, all of them are great. How many people here have ever tried to plug a power supply into a motherboard? A couple of people? Okay, it only goes in one way. You can't turn it another way and still get it to go in without breaking things.
Nowadays, that's true.
Yeah, it didn't used to be. Yeah, it didn't used to be. Yeah, and there's many smoking heaps of motherboards out there.
So much better if we smoke
And
it.
I have friends who work real hard on a heat connector. You can go in the wrong.
Yeah,
Why you thought that?
in that case, you may actually need idiot proofing and not just poka-yoke.
Cables still go into Ethernet jacks.
They do. So that is a case where poka-yoke does not work.
Really annoying.
How many people have ever used the old deck connects? Okay. For those of you that don't know, it looks like an RJ11 phone jack, except rather than the little clicky pin being in the middle that locks it, it's off to the left.
Yeah.
So you can't actually hook a deck terminal up to a phone line and fry it with 45 volts of electricity when the phone rings. This is all examples of obviously not a fan of the deck VG220s.
How many terminals died?
These are all,
Sometimes 110 volts.
yeah, on some cases, yeah, it really, because I thought it was 45 volt DC bus.
I know because in 1983, my mom had needed me to wire up a module connector during the AT&T investment.
Okay?
And, well, we got a phone call, and I was looking for cables. And I was 8. I'll never again.
Yeah, it's not a good idea to hold on to bare phone wires when a phone call's coming in. That's bad. Now, one of the things about poka-yoke, if you discover the failure at the time you've introduced it, there's a single cost associated with it. If you wait till you get to the next step in the process and discover it, the cost is 10 times the cost to fix it. If you wait even further down the sequence, it costs 100 times. For anyone who's ever done anything with the CMMI stuff, they get equivalent costs about discovering the bug in design versus discovering the bug in coding that was a design bug versus discovering that bug after QA and the associated costs with it. It's really quite dramatic. Again, we get a quote from Deming because I didn't set this slide up right. He's actually quoting Dodge on this. Quality is endemic to a product or a process. It is not something you can inspect in. All you can do is detect that it ain't there or that it's poor. That's what inspection gives you. It doesn't give you better quality. Now, this is a control chart. How many people here have ever seen a control chart and know how to read this? We got a couple of people. Okay. I know you were a physics major. Engineering major? Okay, that explains it. Okay. Control charts aren't actually that scary. The one thing to remember on a control chart is there's no statistics behind it. By that I mean you don't need statistical theory for this. It's strictly a heuristic that works. What you have on a control chart, the white lines on the top and bottom, not that are dashed, are the customer specification or customer pain lines. At that point, if you pass those lines, the customer is going to squawk. Then what you have is an upper limit and a lower limit with a median, some sort of measure of central tendency in the middle with the blue line. Between the upper limit and the lower limit should be 99.7% of all of the readings that you get from this process. And if this reading, for instance, can be response times from a web server, it can be average throughput on disk during a particularly heavy period, average percentage disk use. It can be any value you want. But 99.7% of the time is going to be between the upper and lower red limits. You also usually have a 2-sigma line, which indicates that 95% of your data is going to fall in here. And the measure of central tendency, that blue line says 50% of your points are going to fall above it, and 50% of your points are going to fall below it. When you read these things, what you're looking for is something that is out of the ordinary. There's a very low probability of occurring. If between your upper limit and your lower limit is 99.7% of your data, anything that goes above the upper limit or below the lower limit is 0.0015. That is 3 1,000ths divided by 2, because you're splitting it for upper and lower limits. So the probability of this happening is 0.0015. What we have, and that's why that thing is flagged and considered what's called a special cause variation. It's not something that normally happens in the process. It's an outlier. So normally you would go and say, well, what the heck happened there? Why is that happening? Well, we actually had we had like 700 Apache classes running at the time we were doing that measurement, and yeah, it kind of slowed things down.
Then you ask what you're saying.
Exactly. That's an entirely different story. Then you go through the whole demand. We're having random excursions of 700 processes running. What do we do about it? All this is doing is determining you've got a problem, and you're keeping in control. What's happening here in this sort of the middle circle, is you've got a run of 7 on one side of the midline. The chances of a point being on one side of the midline is 50% by definition. 7 of them occurring in a single line is somewhere in the 0.008 range, or 0.8% likely to occur. Hence, this is a potential problem. Yes?
What happens if there is a outlying reason for that?
Then you've got a special cause, and you need to investigate and find out why that special cause is happening. This indicates it's out of control. This is not normal statistical error. There is a cause for this to happen, is what that's saying.
And one thing I found was thunderstorm comes through the top barometric pressure.
Really?
Yeah. Semiconductor manufacturing.
Oh yeah, definitely. Okay, yep.
Arizona fabs, wonderful thing.
Yep, definitely. Now, up here on the upper right circle, notice that occurs above the 2 sigma line. So by definition, it's 2.5% likely to occur. Runs of 2 or of the 3 points is considered a problem. Why? 2.5% squared, which is the probability of getting a run of 2, is 0.0006 probability. Yes?
So you got this cool chart that tells you what happens during your controlled run.
Any run. This continues on till infinity. I plot one of these points every hour.
Okay. So you got data, from say, from some years ago up till today.
Mm-hmm.
How much prediction based upon the past can you make of the future? You know when you have an event that happened.
This particular one does. This particular one does not. There's no correlation between these points. You are actually plotting the individual point.
Right.
Your historical average is determined by what you choose as your upper and lower limits and your 2 sigmas. I actually deployed a new service the other day. What I did is I basically ran my measurement probe for 24 hours and got my data. Then using sort and unique minus C, I figured out what my histogram looks like. I figured out the total number of points. I figured out where 0.003% of my points, 0.3% of my points lied. That was like 9 or 10 points. In my histogram, I went from the end and counted back 9 points. That became my 3 sigma limit.
What I'm saying is, so say you know that you have this event that happens, 0.0015% of the time, and it happens this often over your historical data.
Right. The thing is, it shouldn't be. That should be a special cause. You should be investigating and removing.
Right. But say you don't know the cause yet. You're still going. We don't know why this happened. It happens like once out this often over history. Can you make predictions based upon that, saying at a certain point we might actually see a customer pain event in the future?
Yes, but not necessarily using a control chart. For that, you would probably end up having to rely on other statistical methods. Not using a control chart. That's not really what control charts are designed for. They're really designed for the heuristic of, is my process in control, and if not, when do I need to go investigate it? And what these limits are really doing is allowing you to set the threshold of where you're going to discover a change in the process. Yes, ma'am.
So similar sort of terms that Karen did with the signal trial, something like some sort of reality sort of.
This will work. This will work with a sinusoidal. It's just your limits will be really different. This works regardless of the underlying distribution of the data. That's the beauty of control charts. The data does not have to be normal. It can be periodic.
So you can also
Right.
process the data and take out, those oscillations periodically.
Just subtract the sideways problem.
Right. You certainly manipulate the data to remove that periodicity or something along those lines. The rules for this are the GE rules. If you actually have something that's got an underlying signal to it, you may not necessarily want to measure that signal. You may want to measure something derivative of it. IMR charts, for instance, I think remove that periodicity, which is a type of control chart that I think I removed from this slide deck. And what that actually does, it uses a moving range, the difference between 2 consecutive points, to determine whether things are in control and whatnot. I'm pretty sure there is a control chart that would do that, but I have to do a little bit of research to find out. Yes.
You see a pattern, which makes it not look like it's
Not even look like it's a random variable.
you want to investigate.
Exactly. Exactly.
Enough time
Exactly. So what you actually might want to do is like throw an if you know the underlying theoretical pattern, subtract from it. Basically, it's like removing the mean from a distribution. Move everything to the center line, so all you're looking at is the differences from the mean. In this case, you look at all the differences, say, from your sinusoidal underlying pattern you're expecting to see. And those should be random. That I claim should work. Don't hold me to it.
Ultimately, what this is showing, all of those circle cases are statistically valid. You will encounter a truly random data. But what you're saying is for this chart, those are the places that are most likely to be a non-independently random.
Exactly. They're most likely to be a special cause variation rather than just purely random measurement error.
And therefore worth investigating.
And therefore worth
And therefore worth investigating. Precisely. Precisely. Okay. I like to have the MC hammer. Can't touch this. Dun, 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 dun. This process, if I've drawn it right, is perfectly in control. But yet managers seem to get pissed off at stuff like this and want to tamper with the process. If the process is in control, flap their hands. Don't let them tamper, because chances are they're going to make it worse. This is normal common variation. There is nothing here to worry about. This is perfectly fine. Someone I was talking with many years ago ran a help desk. She actually used to work at GE. And what she actually had were control charts of the number of calls that were coming into the help center per hour. And it was basically plotted. It was a graph that was up in front of all the people in there. All the people knew how to read it. All the people knew what was happening. Somebody came into her office and said, we've exceeded the 3 sigma limit on calls over the past hour. She's like, really? She goes out, looks at it, sure enough. So she had everything set up so the people would automatically, the intake callers would automatically categorize it. They were reliably able to categorize it. They were able to be repeatable, and they were able to be reproducible between categorization. They were pretty accurate. So she ran a fast Pareto chart and saw that the number of network events or network things that were tossed up to network errors outside of the company were very high. For the prior week, the same day on the prior week, they had none of them. They were categorized that way. All of a sudden, this was like the highest thing. This was taking up most of the percentage of the calls that had come in the past hour. She's like, this is weird. So she took a look at the Pareto information it's like, it took like 15, 20 minutes to do this. So she looked at the information for the up to that point in the call chart. It's like, yeah, this is looking at it. She gets on the horn to the networking folks. She says, hey guys, I'm getting a lot of networking calls. They seem to all be coming up unfounded, but something's wrong here. Can you guys check it out? This company was multi-homes from that particular area that was placing all the calls. One of the uplinks was basically black holing everything, and they were set up to load balance between the two of them. So 50% of the time, when you send a packet out, it would go out the link that was black holing everything on the other side of the link. The next time you came around, you'd end up going out the other link, and everything would work fine. That's the power of a control chart. It tells you when something's off, even if you can't necessarily prove it.
They're the key to control charts, something the Pareto charts that part of this.
Exactly. Control chart said, you need to look at this. The Pareto chart said, this looks like what you have, what your problem is. This is the place where you're most likely to see your problem. Yes?
I just said that usually managers will get pissed off because they exceeded 2 sigma but haven't exceeded the red line.
Exactly.
And an example of this was actually a Oak Ridge, back when they were doing the radius operation. The engineers from the scientists out of Los Alamos were going, oh God, these numbers are all so variable, like this is horrible, we got to do this, make it all perfectly consistent. The engineers who were actually running tests said that was fine. So they let the scientists run a portion of plants
Okay.
against their basically high school trained technicians. high school trained technicians exceeded the output of the scientists by about a factor of 2 to 1 to 3 to 1.
Yeah, because the scientists had to tamper.
Exactly.
Yeah, they basically chop off their fingers, people. I'm not kidding about this. Exactly.
No, just came with the keyboards.
Yeah, exactly. Okay, the next one may be somewhat painful to people. I control this control chart of pain. Can anybody tell me what's wrong with this control chart?
Reality and customer theory.
Exactly. The customer expects everything to run within the 2 white lines. The process itself is incapable of doing that. At one point, I actually calculated the area of failure, and it was something like 66% of the time, the customer will be in pain. What do you do in this case? And I've actually had people, when I showed them how to use control charts, they actually went and said, John, it looks like this. What do I do? After I told them to dust off their resumes, I said, B, the process has to be redesigned, or you've got to find out what's causing all this variation. You've got to bring the upper limit and the lower limit inside, and usually well inside the customer pain limits. Or reset the customer expectations such that the customer pain limits fall outside there. But this process, as it is not sustainable. This does not fulfill the customer requirements. And the thing is, if you don't chase stuff like this, if you don't chase the errors in the control charts, if you don't solve the problems as they come up, what ends up happening is your yard gets overgrown. You have to garden, you have to weed. If you don't, you're going to lose the benefits that you got from your original setup. This is where management is key. Companies that I look at, companies I'm familiar with that do this stuff right or semi-right, have the company boards getting reports on what the metrics are from their process improvement and see if they're actually being the same month after month or improving. This has visibility at the very top when you want to keep these gains and keep improving. Now the question is, why do we care about this? It basically comes down to world domination. I'm not saying that if you implement this stuff, your company will become a multi-billion-dollar company and dominate its industry. But I'll tell you what, I'm certainly willing to bet money on it. And that's where the smart money is going to sit if you do this. For further reading, there are too many web resources to mention. Six Sigma, American Society of Quality, Quality Digest. There's a whole litter of them. However, if you're interested in reading something, How to Measure Anything by Hubbard. It's subtitled How to Measure the Intangibles in Business. Very interesting theory on how to measure people and how to get people to do repeatable estimates and measured estimates. Lean Six Sigma for Service by George. One of the few books I found that actually talks about Lean Six Sigma outside of a manufacturing perspective. He's got retrospectives in healthcare, in government process stuff. Quite an interesting book. Go to Barnes & Noble. I actually got a quarter of the way through it and I decided I was going to buy the book. Usually I'll just read these things through while sipping on my lattes. This one I actually bought before I even finished it. For those of you that do Lean in the development environment, Lean from the Trenches by Nyberg. Very interesting book. They were actually developing a computerized system for the police in, I believe it was Sweden. And this discusses how they use Kanban, how they did their flow, and all of the rest of the agile development methodologies they use to succeed in that project. One of the things that people have problems with is quantifying project risk. It's really something you want to be able to measure, but it's really difficult to do. Kendrick has some very interesting ideas about how to do that. And I'm not too ashamed to admit, I read Lean Six Sigma for Dummies. It's got it's very, very nice survey of the tools and things you use to give you a place to jump off to get into the deeper material. One book I do caution against. There's a McGraw-Hill 36-hour Lean Six Sigma. I do not recommend that as a first reading. For some reason I can't quite understand, they seem to invent their own series of words and definitions for things. So when you go and try to look it up on the net to find other information for it, it doesn't exist. Like they don't call value stream mapping value stream mapping. They call it quantification of value add, necessary non-value add, and something else. It's a good book. It's got some useful information in it. But if you read it without really knowing enough in detail to recognize the patterns that they're talking about, it's kind of confusing.
And that's poor quality.
Huh?
That's poor quality.
That is poor quality. Yeah, I claim that, I mean, one of the things that's important about this is everybody have a common vocabulary to discuss this stuff. And that's what ITIL, for instance, brings to the market. That's what the Lean books and Six Sigma, they bring a vocabulary so people talk about things reasonably and have a reasonable understanding of actually understanding each other. Yes?
Have you read Jason Rabbit?
It sounds familiar. I do not believe I have that.
It's Steven Spears decoding of code and GPS.
Okay.
It's actually the creation of an article there.
That may be where I remember it from. That may be where I'm getting the signal from. Yes?
I may focus too much on systems called real-time reaction matters, but the work that John Boyd did on
UDA?
ODA,
ODA? Okay. And who is the author on that?
John Boyd.
Now, challenges. Think of a process at work and analyze it for one of the 8 wastes. I'm sure you've all got your favorite or least favorite process. Go map it out, figure out where the waste is, and try to figure out ways to eliminate it. Choose another process. What measures lets you determine whether or not it was actually being done properly? Try to measure it. Can you make it more reliable? Try to figure out a way to poke you. For you, that does not apply, Nick. You've already figured it out, so you don't have to do that. That's true. It's not. Yeah, that's a good point. Well, it might be your new company. Well, it might be at Northeastern. It might very well be at Northeastern. You never know. Yeah, true enough. Next time you solve a problem, actually go through the DMAIC phases. One of the things that I learned on the ambulance is you'll end up doing things the way you practice it. As soon as we had an occasion of having more patients than we have resources, we fell into an MCI routine, just automatically. So that when we actually had the 78 patients in the overturned bus, it just went. We already had done it in small scale. All we did was we added another 60-odd patients to it. We already knew how to do it because we practiced it. Yes?
For those of us who don't have an EMS background, I have one.
Yep.
What does MCI mean?
Oh, sorry, MCI is multi-casualty incident. Multi-casualty incident. Basically, when you have more patients and you have people that are capable of treating and transporting. Also, it's also the case where you've got more patients than the local hospitals can handle. Now, you get to make me think. Yes, Adam? Oh, 5 minutes? Okay. I realized I ran long. I actually cut out another 15 slides today, so I was running long last night. Okay, quick question before everyone disappears. This is a distillation of a mind map I put together about 4 years ago to teach at Lisa. Does anybody think there's any value in seeing, say, maybe a 4-hour intro class on this at Lisa as a tutorial?
Yes. But like more direct examples into IT.
Yep.
It would make life a lot more addressable.
Yep, I agree.
Possibly outside of the help, excluding help desk, or at least non-help desk stuff.
Yep, agreed.
Yeah. Like they're good.
Mm-hmm.
Some of those are manufacturing countermeasures.
Yep.
So they just wouldn't occur in IT. You get your own measure and something.
Yep. Yeah, I mean, you certainly could replace some of the stuff. Like I said, this was sort of a Lean Six Sigma, so I wanted to give 5 S's comes up anytime anybody talks to me.
But I think it's probably inappropriate because
I think you're really right there.
there are particular countermeasures
Well, yes and no. I mean, certainly you would never use a shadow board in IT to find out which tools are missing. For those of you who don't know a shadow board, think of putting all your tools in place and then painting the whole board. And when you take a tool away, it's obvious where the tool came from. That's called a shadow board. You also get nicely painted tools as well out of it, which makes it more difficult for people to steal them. But I think the concepts of the concepts basically are.
It kind of changes it.
Yeah, exactly.
You can probably discover in your lean processes what the real ones are for particular.
Yep. Yeah, and the whole 5S is kind of a crock anyway. The original concept from the Japanese doesn't really translate to those words. There are better terms for it, but they decided that since all the words in Japanese started with S, for the S sound, they wanted the translations to start with S, so it would be 5S in both languages. And the translations, from what I understand from people who actually speak Japanese, don't really go together all that well. So you're sort of trying to force the meaning of the words in any case. I appreciate your point. In that, and like I said, I've got problems myself with applying 5S to IT. It just seems sort of a mismatch. I'm not quite sure what to do about it.
I wouldn't apply it.
All right, fair enough. Neil, you had a comment? Or somebody else?
It's along the same lines, not just where lean and 5S where it breaks down for IT, but what possible replacements could we have for that instead?
Yeah. That'd be very interesting. I also claim it would be slightly less recognizable to the lean folks, but that's
This is targeting an accessible crowd.
then you certainly need to. Yeah, I certainly need to address that point. Agreed. Yes.
How many lean people are just recognizing things that started with that rather than recognizing actual lean processes? Because if you take like Kanban was a response to some situation in a particular factor. But there may be an entirely different response you want to make to your factor.
Yeah. The question was, how many people are redoing TPS rather than applying the lean principles?
Yeah.
And I think too many people are redoing TPS without understanding the culture from which it comes. Right. You can't really do TPS without trusting and training your line people. Right. So when Detroit tried to do lean, they didn't allow their line workers to stop the line when there was an error on the line, and they were wondering why lean didn't work.
Right.
I think there is truly a disconnect that's partly cultural and partly imagination on our part of how to apply the lean principles within a new environment. And I agree 100% that doing IT and doing service is an entirely different.
It's going to have different countermeasures.
It's going to have different. It's definitely going to have different countermeasures, but the underlying problem and the underlying theory, I think, still applies. Yeah. It's your response to it. Like I said, you don't use a shadow board in IT, but there may be something equivalent that somebody smarter than me is going to have to come up with that works well in IT.
Like control chart is going to be that one. What went from that?
Yep.
It's going to be very different.
Exactly. Yeah. Control charts are a heuristic. They are not. There is no statistical basis on which they're done. They are something that an engineer came up with that says this works to differentiate special cause failure from common cause variation.
It also only works on independent variables that you can keep measuring and that you have a sufficient quantity.
Right.
Okay. So
fortunately, in IT, we've got more variables, independent variables that we know what to do with.
But basically, it's not going to catch things that are rare events.
Right.
So calls per hour is great. Hard disk failures, you're going to be charting this over multiple years. But it's not going to be a good predictor.
However, read failures from your system will often find that.
Yes.
And it's not a matter of checking. Because, yeah, you're right, it's a bathtub curve for the failure of the disk, but actually looking for read failures or other continuous data rather than NT. Well, there actually are N charts and C charts and U charts you can use for that sort of stuff,
The other
failure
thing,
stuff. But
particularly in IT processes, is don't spend $1,000 to save $10.
right.
So at a certain point, just keep the stack of disks beside the server.
Exactly.
It's more cost effective.
Well, remember, one of the things with define is to find the business case for actually solving this problem. That's to solve exactly that issue.
The problem with that cost $1,000 is just
There's a business case. We can attract better employees.
One problem, one comment from a bigger sense, right? Like, I mean, in a way, you're dealing with people, like, this is sort of optimizing a process that, in a way, if you have a bunch of engineers that people are already on board with, but that sort of presumes a lot in a lot of organizations, right? Like, you could try to put all these things in, and people, like, I'm not so sure that the just-in-time thing, I mean, look, it hasn't really worked outside of Toyota, or at least it took a long, long time for people to sort of move to that,
Owen's
right?
got it.
Huh?
Owen's got it down pat.
Yeah, but these are very highly technical products, and the technicians are, I mean, they're sort of, it's self-selecting for people that are inclined to think that, okay, we do want to make a product better, whereas most, you know, you walk into a Dunkin' Donuts and people are not thinking about how they can make a company.
Actually, that is true, but you'd be surprised if you look at Starbucks and their supply chain, their supply input output, they do just in time.
Yeah, now, but I'm just saying
But
that
they
it's a long
didn't-
time.
right.
I'm just saying, there's a reason that Toyota came out of a Japanese culture. I mean, not to, I think that it's not
Yes,
that
because
surprising.
Japan, well, the reason that Japan got laid to waste during World War II, and Shewhart and Deming went over there along with some of the other people to train them on how to do things.
Yeah, but I'll look at the bigger picture. I'm just saying that I think, you know, everything we can agree that what you're saying is great, but we're also predisposed to agree that we want to improve processes.
Yeah, agreed.
As a way, and how do you apply this in a situation?
Like I said, you know, my requirements for actually making this work, management approval, that's what you really do need that. You need buy-in across the board, or at least within the group in which you can have some degree of control and some degree of management buy-in to protect you from upper management basically trying to screw with things. Yeah, agreed. I agree 100%. Thank you. Please feel free to take sticker swag.